Okay, hello everyone. So, sa video ito nais kong i-share sa inyo ang about sa pag-check ay pag-determine ng fault rating ng protective devices. So, dahil sa may ginagawa kong as a freelance electrical engineer, may ginagawa kong design review. So, ngayon, i-share ko na rin yung ang topic is about the fault rating of the protective devices. Okay, so let's say for example we have a sample power system. Let's say this is the utility, and we have the transmission lines or cables, and we have the bus. Let's say this is bus 1, and from the bus we have the loads. Let's say loads, so let's say this is a motor loads. Okay, and another loads here, and of course you have the protective devices, and we have another transmission lines or cables. Then in the end we have a distribution transformer. Okay, let's say this is the transformer TX, and of course you have here the protective device also. And let's say the transformer, the voltage is 13.8 kV primary, and the secondary is 440 volts. Okay, then another cables or transmission lines, then you have another bus. Of course you have a protective device, and let's say you have a load and also a protective device, and you have the motor loads also. You have a protective device. Okay, let's say this is bus 2. Okay, now for me, pag nag-check ako ng power system, so pag yung mga fault rating ng mga protective devices, so here meron tayong bus 1 and bus 2, and of course the protective devices are connected in each bus. So meron tayong bus dito, meron din tayong bus dito. Okay, so first you should have to calculate the fault current or the available fault current in every bus. So let's say for example here, let's say this is fault 1 and this is fault 2. So why it is important to calculate the fault current in every bus? Because most of the protective devices, controllers or motor control centers are connected in the bus. Okay, right? So of course the protective device, you have to determine the fault rating also. That's why we need to calculate the fault current in every bus. Okay, so next you have to indicate the voltage. It's up to you, but for me this is the way I review a power system. So you have the voltage here from the utility up to the primary terminals of the transformer. So here from utility up to the primary terminals is the voltage is 13.8 kV. Okay, next from the secondary terminals of the transformer up to the final loads, the voltage is 440 volts. Okay, next So since you have now indicated the voltage level in the power system, so here the protective devices in bus 1, the voltage is 13.8 kV, while here in the in bus 2, the voltage is 440 volts. So what are those rating that we need to determine? Okay, so as per the ANSI standard or IEEE, it is said that for the if the voltage is more than 600 volts, I say 600 volts more than, the fault rating that we need to determine is A is momentary rating and interrupting rating. So interrupting rating. So you have to take note this. Then for the if the voltage is less than 600 volts, you have to determine only the interrupting rating. Then if you are preparing the impedance diagram, let's say this is interrupting rating. Why only interrupting rating? Because the low voltage breakers are fast tripping device. Okay, so if you are preparing the impedance diagram when you are calculating the fault current, so you have to consider the subtransient reactance of the sources of short circuit currents. So what are the sources of short circuit currents? Of course, you have the motors and generators. Okay, so once again, okay, so if the voltage is more than 600 volts, so you need to determine the momentary rating and also the interrupting rating. If 600 volts less than, you need also to determine the interrupting rating. Okay, so here from this power system, the protective devices here is more than 600 volts, so you need to determine the momentary and interrupting rating. So what is momentary? This is the fault current that includes the DC components. So meaning the AC components and the DC components are added. And also when you are preparing the impedance diagram, there you have to have a separate impedance diagram for calculating the momentary rating and another impedance diagram for the interrupting rating, because the reactances of the motors are different for the momentary and the interrupting rating, and that will be discussed in the next video. So that's all for this video. So let's have a summary. The protective devices in bus 1, you have to again determine the momentary rating and the interrupting rating. And for the low voltage or less than 600 volts in this bus, you need to determine the interrupting rating only of the protective devices. And of course, you have to perform the fault current calculations, and we will discuss that also in the next videos. So that's all for this video. Thank you and God bless.